Welcome to another episode of Sleepy Space. Imagine, if you will, that you are floating in the deepest ocean of space, surrounded by a silence so complete it feels like a gentle embrace. Here in the vast cathedral of the cosmos, your body weightless and your mind free to wander, you begin to sense something extraordinary. The darkness around you is not empty. It pulses with invisible currents, subtle tides that have been flowing for billions of years before you were born and will continue long after your earthly journey ends. This is the realm of gravity, that most gentle and persistent of all forces. You know gravity intimately from your daily life. It's the force that keeps your feet planted on the ground, that pulls raindrops from clouds, that makes your morning coffee settle into your cup. But here, in the profound depths of space, gravity reveals its true nature as the universe's great sculpture, the invisible artist that shapes everything from the smallest pebble to the most massive galaxy. Feel yourself drifting toward understanding as you contemplate this remarkable force. Gravity is not aggressive or violent, it simply is. It flows like honey, patient and persistent, never rushing, never forcing. It whispers rather than shouts, and yet its whispers have built every star, every planet, every grain of sand beneath your feet. When you walked on the beach this morning, you were treading on matter that gravity had been gathering and shaping for eons. Now let your imagination carry you deeper into space, where gravity begins to reveal its more profound mysteries. Picture a star, massive and brilliant, burning with the fire of nuclear fusion for millions of years. This star is not unlike our sun, but perhaps 10, 20, or even 50 times more massive. For most of its life, this stellar giant exists in perfect balance. Gravity pulls inward, trying to collapse the star, while the tremendous heat and pressure from nuclear reactions push outward, keeping the star inflated like a cosmic balloon. This dance between gravity and nuclear fire is one of the universe's most elegant waltzes. You can almost hear the rhythm of it, the slow, steady pulse of a star's heartbeat echoing across the light years. The star breathes in and out over thousands of years, growing and shrinking by minute amounts, like a sleeping giant whose chest rises and falls with each cosmic breath. But eventually, like all living things, the star begins to age. The nuclear fuel in its core starts to run low, and the delicate balance that has sustained it for so long begins to shift. The outward pressure weakens, and gravity, patient, persistent gravity, begins to win the ancient struggle. The star's core begins to contract, slowly at first, then faster as gravity pulls more and more matter inward. What happens next is both beautiful and profound. As the core contracts, it becomes denser, and as it becomes denser, its gravitational pull becomes stronger. It's like rolling a snowball down a hill. The bigger it gets, the more snow it picks up, and the faster it rolls. The star's gravity becomes so intense that it begins to pull in not just matter, but space itself. The very fabric of the universe starts to bend and curve around this incredibly dense object. This is where our story becomes truly magical. You see, space and time are not separate things. They are woven together into what scientists call space-time, like threads in a cosmic tapestry. When you walk across a room, you're not just moving through space, you're moving through space-time. And when gravity becomes intense enough, it can actually bend this tapestry, creating curves and valleys in the fabric of reality itself. Imagine space-time as a vast, stretched rubber sheet. If you place a marble on this sheet, it creates a small dimple. A bowling ball creates a larger dimple. But if you could somehow place an object infinitely dense at a single point, it would create a dimple so deep that nothing, not even light itself, could climb back out. This is the birth of what we call a black hole, although that name hardly does justice to these remarkable objects. The term black hole makes them sound like empty voids, cosmic vacuum cleaners that devour everything in their path. But this couldn't be further from the truth. A black hole is not a hole at all. It's an object, incredibly dense and massive, with gravity so strong that it bends space-time into a closed loop. It's more like a cosmic seed planted in the garden of space, around which new structures and patterns can grow. Think of how a garden works. When you plant a seed in soil, it doesn't destroy the garden, it organizes it. The seed draws nutrients from the surrounding earth, and over time it grows into something beautiful and complex. The matter around it doesn't disappear, it becomes part of something greater. In much the same way, black holes don't destroy the universe, they organize it, creating structure and order from the chaos of random matter floating through space. As you float in your cosmic reverie, you begin to understand that black holes are not the monsters of space they are often portrayed to be. They are the universe's master recyclers, patient gardeners who gather material from their surroundings and transform it into something new. They are the places where the universe does its most profound thinking, where matter and energy dance together in ways that stretch our understanding of what's possible. The gravity of a black hole is so intense that it slows time itself. Near the edge of a black hole, time moves more slowly than it does here on Earth. If you could somehow observe a clock falling toward a black hole, you would see it tick more and more slowly as it approached the point of no return. This isn't science fiction. It's the way the universe actually works, as confirmed by our most precise measurements and observations. But perhaps the most beautiful aspect of black holes is how they connect everything in the universe. The same force that created the black hole, gravity, is at work everywhere, from the smallest asteroid to the largest galaxy. Every breath you take, every step you walk, every dream you dream is influenced by the same cosmic force that shapes these mysterious objects. You are part of the same story, woven into the same tapestry of space-time. As you drift deeper into sleep, carried by these gentle thoughts of cosmic connection, you begin to sense that there is something more to discover about these gravitational giants. For at the edge of every black hole lies a mysterious boundary, a place where the normal rules of physics begin to transform into something altogether more strange and wonderful. A threshold that scientists call the event horizon, where time itself begins to whisper secrets that have been waiting billions of years to be understood.
You find yourself approaching something that exists nowhere else in your everyday experience, a boundary that is not made of matter, not built of stone or metal or any substance you could touch. This is the event horizon, the gentle threshold that surrounds every black hole like an invisible sphere of profound significance. Its name whispers of events and horizons, of things that happen and limits that can be seen. But like so many things in the cosmos, it is far more subtle and beautiful than its simple description might suggest. Imagine standing at the edge of a vast, perfectly calm lake at twilight. The water is so still it reflects the sky perfectly, creating a mirror that seems to double the world. You can see exactly where the water meets the shore, that gentle line where one realm becomes another. The event horizon is similar. It marks the place where one region of space-time becomes another, where the familiar laws of physics you know from Earth begin to transform into something altogether more mysterious. But unlike the edge of a lake, you cannot see the event horizon itself. It reveals itself only through its effects, like the way you know the wind is blowing by watching leaves dance in the air. The event horizon is defined by light, specifically by the fact that light itself cannot escape from within it. This might sound frightening, but consider how light behaves in this cosmic boundary, and you'll discover something far more beautiful than terrifying. Light, as you know, is the fastest thing in the universe. Nothing can travel faster than light. Not spaceships, not particles, not even information itself. Light sets the ultimate speed limit for everything that exists. When you flip a switch in your bedroom, the light that fills the room travels at this cosmic speed limit, about 186,000 miles per second. At that speed, light could circle the Earth more than 7 times in a single second. Yet here, at the event horizon, even light must surrender to the gentle but inexorable pull of gravity. Picture a photon, a single particle of light, approaching the event horizon. This photon might have been born in a distant star, traveled across the galaxy for thousands of years, witnessed the birth and death of worlds, carried the warmth of distant suns across the cold vacuum of space. As it approaches the black hole, something remarkable begins to happen. The photon doesn't suddenly stop or crash into an invisible wall. Instead, it begins to follow the curved paths that gravity has carved into space-time itself. Think of space-time around a black hole as a vast funnel, smooth and continuous, growing steeper and steeper as it approaches the center. The photon follows this curved path like a marble rolling around the rim of a funnel, spiraling inward. From the photon's perspective, it is still traveling in a straight line at the speed of light, just as it always has. But the space through which it travels has become so curved that what was once a straight line to the outside universe now becomes a path that curves back toward the black hole. This is the event horizon's first secret. It is not a barrier in the traditional sense, but rather a region where the geometry of space itself has become so curved that all paths lead inward. It's like being in a room where every door you open leads to the same place, deeper into the room itself. The photon continues to travel at the speed of light, following what it experiences as a straight line, but that line has been gently curved by gravity into a closed loop. From your perspective, watching from a safe distance, something even more extraordinary occurs. As objects approach the event horizon, they appear to slow down. Time itself, which you might think of as the steady, unchanging beat of the universe's metronome, begins to stretch and flow like honey. This isn't an illusion or a trick of perception, it's a fundamental feature of how time works in the presence of strong gravitational fields. Einstein showed us that time and space are intimately connected, woven together into the fabric of space-time. When gravity bends space, it also bends time. Near the event horizon, time flows more slowly than it does in the regions of weaker gravity where you observe from. If you could somehow send a clock toward the event horizon and watch it through a powerful telescope, you would see it tick more and more slowly as it approached the boundary. The clock wouldn't break or malfunction. Time itself would be running more slowly there. This time dilation creates one of the most poetic aspects of black holes. Imagine a star that is falling toward the event horizon. As it approaches this cosmic boundary, the light from the star becomes redder and dimmer, not because the star is dying, but because time is slowing down around it. The star's light waves are stretched out, like the sound of a train's whistle dropping in pitch as it moves away from you. Eventually, the star appears to freeze at the event horizon, its light becoming so red and dim that it fades from view, even though from the star's own perspective, it continues falling inward without ever feeling that it has stopped. This creates a beautiful paradox that reveals the subjective nature of time itself. From the outside, objects appear to take forever to cross the event horizon, their time slowing to a crawl and eventually stopping. But from the perspective of something crossing the event horizon, time flows normally. The falling object experiences nothing unusual as it passes through this boundary. No jolt, no sensation of crossing a threshold. It simply continues its journey inward, following the curved paths that gravity has laid out through space-time. The event horizon thus becomes a place where different perspectives on reality can coexist. It's a boundary that is simultaneously impermeable and permeable, depending on where you stand in space-time. This duality reflects something profound about the nature of the universe itself, that reality is not a single fixed thing, but rather a tapestry of interconnected perspectives, each valid and meaningful in its own context. As you contemplate this boundary between the known and unknown, you begin to understand that the event horizon is not an ending, but a transformation. It is the place where matter and energy begin their journey into a realm where the familiar rules of physics become something new and strange. Beyond the event horizon lies a region where space and time themselves dance to different rhythms, where the very concept of here and there begin to lose their everyday meaning. The event horizon whispers to us about the nature of boundaries in general. In your own life, you cross invisible boundaries every day. The moment you wake up, the instant you understand a new idea, the threshold between being alone and being with others. These boundaries, like the event horizon, are not walls, but transitions, places where one state of being becomes another. The gentleness of the event horizon, its non-dramatic nature, its smooth and continuous inevitability, reminds us that some of the most profound changes in the universe happen not with violence or chaos, but with the quiet inevitability of natural law. The event horizon is not a cosmic prison, but a cosmic chrysalis, a place where matter and energy prepare for their next transformation in the great recycling process of the universe. As you drift deeper into contemplation, you sense that beyond this threshold lies something even more mysterious and beautiful. The event horizon is just the beginning of the story, the first chapter in a tale of cosmic transformation that will carry us into the very heart of space-time itself, where the universe performs its most elegant and mysterious dance. The event horizon teaches us that boundaries in the universe are not walls, but invitations to transformation. Like the moment when day becomes night, or when a caterpillar becomes a butterfly, these cosmic boundaries mark places where one form of existence gracefully becomes another. The event horizon is the universe's way of saying that some mysteries are meant to be experienced rather than observed. That some journeys require us to let go of our need to understand everything from the outside. Consider how this relates to your own experience of boundaries and thresholds. When you fall asleep each night, you cross an invisible boundary between waking and dreaming. You don't experience this crossing as a dramatic event. One moment you're awake, thinking about your day, and the next you're dreaming of impossible things. The transition is seamless, gentle, natural. The event horizon works in the same quiet way, a threshold that is crossed not with violence, but with the same quiet inevitability as sleep. The mathematics that describe the event horizon are among the most beautiful in all of physics. They speak of spheres within spheres, of radii that depend on mass, of relationships between space and time that are as elegant as they are profound. For a black hole with the mass of our sun, the event horizon would be about 3 kilometers from the center, a sphere about 6 kilometers across, smaller than most cities.
You are lying quietly now, your breathing slow and steady, your mind drifting between waking and sleeping. But even in this peaceful state, you are moving through space at incredible speeds. The Earth carries you around the Sun at 67,000 miles per hour. The Sun carries you around the galaxy at 514,000 miles per hour. The galaxy itself moves through the universe at over 1 million miles per hour. Yet you feel perfectly still, cradled in the gentle embrace of forces so vast and smooth that they seem like cosmic lullabies. This is your first hint of the symphony that surrounds you, a music made not of sound waves traveling through air, but of gravitational waves traveling through the very fabric of space-time itself. These waves are the universe's most ancient songs, melodies that have been playing since the first massive objects began their cosmic dance billions of years ago. Tonight, as you rest, these waves pass through your body, through your dreams, connecting you to events that happened when the universe was young and wild. Imagine space-time as a vast ocean, deeper than any earthly sea, stretching in all directions beyond the reach of imagination. This ocean is not filled with water, but with the very essence of reality, the dimensions of space and time woven together into a single flowing medium. When you move through your daily life, you create tiny ripples in this ocean, disturbances so small they are nearly impossible to detect. But when truly massive objects move through space-time, they create waves that travel across the entire universe. The most beautiful of these waves are born when two black holes find each other in the darkness of space. Picture this cosmic romance. Two massive objects, each the compressed heart of a star that lived and died billions of years ago, slowly spiraling toward each other across the eons. Their dance begins when they are separated by distances greater than the width of entire solar systems, their gravitational fields barely touching across the vast emptiness of space. At first, their orbital dance is leisurely, almost contemplative. They circle each other once every few hours, taking their time, following the gentle curves that gravity has laid out in space-time. But as they orbit, they lose energy to gravitational waves, those ripples in space-time that carry their orbital motion away like cosmic breath. As they lose energy, they move closer together, and as they move closer, they orbit faster. The process is so gradual that if you could watch it, you would see no change from 1 year to the next, or even from 1 century to the next. These black holes are patient dancers, content to slowly approach each other over millions of years. But eventually, inevitably, they reach a point where the dance accelerates. Their orbits become tighter, their speeds become faster, and the gravitational waves they create become stronger and more frequent. In the final moments before they merge, these two black holes orbit each other hundreds of times per second, moving at significant fractions of the speed of light. The gravitational waves they create are no longer gentle ripples, but powerful surges that stretch and squeeze space-time itself. If you could somehow tune your body to feel these waves, you would experience the universe itself, breathing rapidly, pulsing with the rhythm of this cosmic finale. The moment of merger is both violent and beautiful. Two objects that have existed separately for billions of years suddenly become one, their event horizons touching and merging like soap bubbles joining together. The space-time around them rings like a bell that has been struck, sending out gravitational waves that carry the story of their union across the cosmos. In less than 1 second, this cosmic collision releases more energy and gravitational waves than all the stars in the observable universe emit in light. These waves spread outward at the speed of light, carrying with them the signature of the event that created them. Like the ripples that spread when you drop a stone into a still pond, gravitational waves carry information about their source. The frequency of the waves tells us about the masses of the objects that created them. The pattern of the waves reveals the nature of their dance. The strength of the waves, when they finally reach us, tells us how far away the collision occurred. By the time these waves reach Earth, they have been traveling for millions or billions of years, crossing distances so vast that the light from the collision may not reach us for eons to come. These waves arrive as gentle undulations in space-time, stretching and squeezing the distances between objects by amounts smaller than 1,000th of the width of a proton. Yet, incredibly, we have built instruments sensitive enough to detect these whispers from the cosmic deep. The Laser Interferometer Gravitational Wave Observatory, known as LIGO, consists of 2 facilities thousands of miles apart, each containing lasers that travel down perpendicular arms several kilometers long. When a gravitational wave passes through Earth, it stretches space in one direction while squeezing it in the perpendicular direction. This stretching and squeezing changes the time it takes light to travel down the arms by amounts so tiny that they require the most precise measurements ever made by human beings. When LIGO first detected gravitational waves in 2015, it was like suddenly developing a new sense. For all of human history, we had explored the universe through electromagnetic radiation, visible light, radio waves, X-rays, and gamma rays. But gravitational waves gave us our first direct experience of how space-time itself moves and flows. It was as if we had been watching a movie of the universe our entire lives, and suddenly we could hear the soundtrack. The sound of these gravitational waves, when converted to audio frequencies, is hauntingly beautiful. The final moments before 2 black holes merge create a characteristic chirp, a rising tone that starts low and rises in pitch and volume until it suddenly stops. This chirp is the death song of two massive objects and the birth cry of something new. It's a sound that carries the story of stellar evolution, of nuclear fusion, of collapse and rebirth, compressed into a fraction of a second. But black holes are not the only objects that create gravitational waves. Neutron stars, those incredibly dense remnants of massive stars, also dance together in binary systems. When two neutron stars merge, they create gravitational waves with their own distinctive signature, different from the deep bass notes of merging black holes. These neutron star mergers also create brilliant flashes of light, allowing us to observe the event with our traditional telescopes and our gravitational wave detectors. The universe is full of these cosmic instruments, each playing its own part in the gravitational symphony. Rapidly rotating neutron stars, called pulsars, create continuous gravitational waves as they spin, like cosmic lighthouses, sending out steady beams of space-time distortion. White dwarf stars in binary systems create gravitational waves as they orbit each other. Even the Big Bang itself may have left its signature in the form of primordial gravitational waves, the echo of the moment when space and time first began their eternal dance. As you lie in the darkness, these waves are passing through you right now. Your body, your bed, your room, your entire world is gently expanding and contracting as gravitational waves from distant cosmic events wash over you. The effect is so small that you cannot feel it, but it is real and measurable. You are quite literally being touched by events that happened billions of years ago, in places billions of light years away. This connection across vast distances and times reveals something profound about the nature of reality. The universe is not a collection of separate, isolated objects, but a single, interconnected whole. The gravitational waves that pass through you carry information about the deaths and births of stars, the formation and evolution of galaxies, the very expansion. As you float in the peaceful space between waking and sleeping, your mind drifts toward a vision of the most extraordinary laboratory in the universe. This is not a place built of glass and steel, filled with beakers and test tubes, but rather a cosmic workshop, where the fundamental building blocks of reality are transformed in ways that would make the ancient alchemists weep with wonder. Here, around the gentle giants we call black holes, the universe performs its most profound acts of creation, turning the simple into the complex, the ordinary into the extraordinary. Picture yourself approaching one of these cosmic laboratories from a safe distance, your consciousness floating through space like a patient observer. At first, you might see nothing but the familiar darkness of deep space, punctuated by the distant light of stars. But as you draw closer, you begin to notice something remarkable. A faint glow emanating from what appears to be empty space, a subtle radiance that speaks of processes more energetic than anything happening in the cores of stars. This glow comes from the accretion disk, a magnificent spiral of matter that surrounds the black hole like a cosmic whirlpool. Imagine a vast, flattened disk of gas and dust stretching across distances that could encompass entire solar systems, rotating slowly at its outer edges, but accelerating to tremendous speeds as it spirals inward. This is where the universe does some of its most intricate work, where the atoms that make up your body, the oxygen you breathe, the carbon in your DNA, undergo transformations that reveal the deep connections between all things. The matter in the secretion disk has traveled incredible distances to reach this place. Some of it may have been born in the nuclear furnaces of stars that lived and died billions of years ago, their atoms scattered across the galaxy when those stars exploded as supernovae. Other particles may have been wandering through interstellar space for eons, part of the thin gas that fills the regions between stars. But now, drawn by the inexorable pull of gravity, all of this matter has found its way to this cosmic laboratory. As you watch this cosmic ballet, you notice that the accretion disk is not uniform or simple. It has structure, beauty, complexity that rivals any work of art. The inner regions glow with intense heat, their temperature rising to millions of degrees as friction transforms the kinetic energy of orbital motion into light and heat. The outer regions are cooler and darker, like the calm suburbs of this cosmic city, where matter moves more slowly and patiently waits its turn to spiral inward. The colors of the accretion disk tell the story of temperature and transformation. The outermost regions might glow with the deep red of relatively cool matter, perhaps a few thousand degrees, hot enough to melt any earthly substance, yet cool by the standards of this cosmic forge. As you look inward, the colors shift through orange and yellow, then to brilliant white and blue as the temperature climbs into millions of degrees. At the very center, where matter makes its final approach to the event horizon, the disk blazes with X-rays and gamma rays, radiation so energetic it could sterilize entire worlds. But this is not destruction. It is the universe's most sophisticated recycling program. The atoms spiraling inward in the accretion disk are not being destroyed, but transformed. Their electrons stripped away by the intense heat, their nuclei liberated from the chemical bonds that once held them in molecules. The carbon atom that was once part of a complex organic molecule in a distant world becomes a bare nucleus, free to participate in new kinds of interactions. The oxygen that once helped form water on some long-dead planet now glows with the fierce energy of plasma heated to cosmic temperatures. The magnetic fields threading through the accretion disk add another layer of complexity to this cosmic laboratory. These magnetic fields, generated by the motion of electrically charged particles, create invisible highways and barriers that guide the flow of matter. Some particles follow these magnetic field lines inward, while others are accelerated outward in tremendous jets that can extend for thousands of light years. These jets are among the most powerful phenomena in the universe, beams of matter and energy that travel at nearly the speed of light, carrying material from the black hole's vicinity back out into the broader cosmos. Think of these jets as the universe's way of breathing. The black hole breathes in through its accretion disk, gathering matter from the surrounding space. But it also breathes out through these jets, sending processed material back to the cosmos, enriched and transformed by its journey through the gravitational crucible. This breathing process connects the black hole to the galaxy around it, making it not just a passive gravitational anchor, but an active participant in the cosmic ecosystem. The transformation happening in the accretion disk is not random or chaotic. It follows precise physical laws, governed by the same principles that shape the gentle fall of raindrops and the orbit of planets. The temperature at each point in the disk depends on the rate at which gravitational energy is converted to heat. The magnetic fields organize themselves according to the fundamental laws of electromagnetism. Even in this most extreme environment, the universe maintains its commitment to order and beauty. As matter spirals inward through the accretion disk, it experiences a journey unlike anything possible elsewhere in the universe. The tidal forces of the black hole stretch and compress each particle like cosmic hands gently kneading dough. The magnetic fields accelerate charged particles to tremendous speeds, creating cosmic rays that will eventually travel throughout the galaxy. The intense radiation environment transforms the very nature of matter, ionizing atoms and molecules, breaking complex structures down into their fundamental components. But perhaps the most remarkable aspect of this cosmic laboratory is how it creates new possibilities for matter and energy to interact. In the extreme conditions near a black hole, particles can achieve energies that dwarf anything we can create on Earth. When these high-energy particles collide with each other, or with photons of light, they can create new particles, new forms of matter that exist only in these extreme environments. The accretion disk becomes a cosmic particle accelerator, exploring the fundamental laws of physics at energy scales that reveal the deepest secrets of reality. The time dilation effects near the black hole add yet another dimension to this cosmic laboratory. Time flows more slowly in the strong gravitational field near the event horizon, which means that processes that would take seconds in the outer regions of the disk might take minutes or hours in the inner regions. This creates a kind of temporal layering, where different parts of the disk exist at different rates of time. The black hole becomes not just a spatial laboratory, but a temporal one, where the effects of relativity can be studied in their most extreme form. The light emitted by the accretion disk carries with it the story of these transformations. Each photon is a messenger, carrying information about the conditions where it was created. The spectrum of this light tells us about the temperature, density, and magnetic field strength in different regions of the disk. By analyzing this light, astronomers can peer into the cosmic laboratory and understand the processes happening there, even though the black hole itself remains hidden behind its event horizon. The accretion disk also serves as a cosmic clock, recording the history of the black hole's growth and evolution. Material that falls into the black hole today joins matter. You have traveled far on this cosmic journey, from the gentle pull of gravity to the edge of forever, from the symphony of space-time to the alchemical laboratories of the stars. Now, as you rest in the peaceful space between sleeping and waking, you arrive at the most beautiful truth of all, that the universe is not a place of endings, but of eternal beginnings, not a story of destruction, but of endless renewal. The black holes that seemed so mysterious and forbidding at the start of our journey reveal themselves to be the universe's most patient and generous gardeners. Imagine yourself floating in a cosmic garden that stretches beyond the reach of imagination, where the growing seasons are measured not in months, but billions of years. where the seeds planted today will bloom into galaxies tomorrow. This is the ultimate perspective on black holes, not as cosmic monsters devouring everything in their path, but as careful cultivators of the universe's future, slowly and patiently preparing the conditions for new forms of beauty to emerge. The most remarkable aspect of this cosmic garden is how it operates on timescales that dwarf human comprehension. While you live your life in days and years, the universe thinks in epochs and eons. The black hole that swallowed a star yesterday, from the universe's perspective, is performing an act of cosmic agriculture that will benefit creatures not yet born on worlds not yet formed. Every particle that crosses the event horizon becomes part of a process so vast and slow that it can only be appreciated from the perspective of cosmic time. This brings us to one of the most beautiful discoveries in modern physics, the revelation that black holes are not perfectly black, not eternal prisons from which nothing can escape. Through the patient work of a brilliant physicist named Stephen Hawking, we learned that black holes actually glow with a subtle radiance, emitting what we now call Hawking radiation. This discovery transformed our understanding of black holes from objects of pure absorption to objects of gentle emission, cosmic fountains that slowly return everything they have gathered back to the universe. Hawking radiation emerges from the quantum nature of reality itself. Even in the vacuum of space, pairs of particles are constantly being created and destroyed, flickering in and out of existence like fireflies in a summer evening. Usually, these particle pairs annihilate each other immediately, leaving no trace of their brief existence. But near the event horizon of a black hole, something magical happens. Sometimes one particle from a pair falls into the black hole, while the other escapes, carrying away a tiny amount of the black hole's energy. This process is so gentle, so subtle, that it would be invisible to any ordinary observation. The Hawking radiation from a black hole with the mass of our Sun would be colder than the cosmic microwave background radiation that fills the universe, colder than the space between galaxies. Yet this radiation is real, and over vast periods of time, it slowly causes the black hole to lose mass and energy, gradually returning everything it has gathered back to the cosmos. The beauty of Hawking radiation lies not in its intensity, but in its persistence. Like a patient gardener who tends to plants with daily care, the black hole slowly and steadily gives back to the universe. The process is so gradual that a black hole with the mass of our Sun would take longer than the current age of the universe to lose even a tiny fraction of its mass. But the universe is patient, and cosmic time is generous. Eventually, every black hole will evaporate completely, returning all of its mass and energy to the cosmos. As a black hole evaporates through Hawking radiation, it undergoes a remarkable transformation. The smaller it becomes, the hotter its radiation becomes, and the faster it evaporates. This creates a beautiful feedback loop, where the final stages of a black hole's life are like a cosmic fireworks display, releasing tremendous amounts of energy in a brilliant flash that lights up the darkness of space. This final burst of radiation carries with it the information and energy from everything that ever fell into the black hole, returned to the universe in a form that can participate in new cycles of creation. But Hawking radiation is not the only way black holes give back to the universe. The jets we explored in the previous chapter carry processed material away from black holes at nearly the speed of light, distributing heavy elements throughout the galaxy. These jets can extend for thousands of light years, carrying the products of stellar nucleosynthesis to regions where new stars are forming. The iron in your blood, the oxygen in your lungs, the carbon in your DNA. Some of these atoms may have been processed through the cosmic laboratories of black holes before becoming part of your body. The gravitational waves created by merging black holes also contribute to the cosmic garden. These ripples in space-time carry energy away from the black hole system, slowly causing the orbits of binary black holes to decay. When two black holes finally merge, they create a new black hole that is actually less massive than the sum of its parts. The missing mass is converted into gravitational wave energy that spreads throughout the universe, carrying the story of the merger to distant worlds and perhaps triggering new processes in the cosmic ecosystem. The role of black holes in galaxy formation and evolution reveals another aspect of their nurturing nature. The supermassive black holes at the centers of galaxies are not just passive inhabitants, but active participants in galactic ecology. They regulate star formation by controlling the flow of gas and dust, preventing galaxies from forming stars too quickly and using up all their material. Like a wise gardener who knows when to water plants and when to let them rest, these cosmic giants help pace the process of cosmic evolution. The feedback loops between black holes and their host galaxies create a kind of symbiosis. The black hole grows by accreting material from its surroundings, but as it grows, it releases energy that heats the surrounding gas, preventing too much material from falling in. This self-regulating process ensures that galaxies can continue forming stars for billions of years, creating a sustained and balanced ecosystem that supports the long-term evolution of complexity in the universe. As you contemplate these cosmic cycles, you begin to understand that you are part of this eternal garden. The elements in your body were forged in the cores of stars, scattered by supernovae, perhaps processed through the accretion disks of black holes, and eventually incorporated into the molecular machinery of life. You are made of star stuff, as the astronomer Carl Sagan once said, but you are also made of black hole stuff, cosmic recycling stuff, the processed material of the universe's most patient gardeners. The atoms in your body have been part of many different structures over the billions of years since they were created. They have been part of interstellar gas clouds, stellar cores, planetary atmospheres, and countless other cosmic environments. Some of them may have crossed the event horizons of black holes and been returned to the universe through Hawking radiation. Others may have been accelerated to tremendous speeds in black hole jets and carried to distant regions of the galaxy. All of them have been part of the grand cosmic recycling process that has been ongoing since the universe began. This cosmic recycling connects you to the deepest processes of the universe itself. When you breathe, you are participating in cycles that began billions of years ago in the hearts of stars. When you think, you are using neural networks built from atoms that may have been processed through some of the most extreme environments in the cosmos. When you dream, you are dreaming with matter that has been part of the universe's long journey from simplicity to complexity, from the first hydrogen atoms to the intricate biological machinery of consciousness. The black holes scattered throughout the universe are like seeds planted in the cosmic garden, slowly growing and eventually releasing their stored material back to the cosmos. Some of these seeds will take trillions of years to mature, slowly evaporating through Hawking radiation and returning their material to the universe. Others will merge with their companions, creating gravitational waves that